Hey there, in this video I'm going to show you how you can calculate functions on a two-dimensional grid, typically with the intent to plot them. So suppose we have a problem. We want to plot sine x plus sine y. Okay, so sine x plus sine y. And so I showed you in an earlier video how you can use a nested for loop to calculate element by element in a two-dimensional array. You basically never want to do that though, because it's really slow. The way I'm going to show you here uses arrays natively, and it is super fast compared to the other way. And it uses less code, it's a little bit easier to understand. And so it's going to be our preferred way for making two-dimensional data. So let me show you how you'd write the code first, and then we're going to dig into how it works after. So I'm going to start here with what x values and y values I want to use. Since these are trig functions, values around pi make sense. So let's go 0 to 2 pi for the x and the y. So for the x direction, I can use a linspace or an arange. I'm going to use linspace 0 to 2 pi. And let's do 100 steps. And then the y values will be just the same. Oh, we could copy those. I mean, I could literally write y values equals x values, but let me just put them on separate lines. So I've got our x values, got our y values. And now the next line here is going to be what looks like magic. It's really the heart of what makes this all work. And like I said, we'll dig into it after we finish the example. So we're going to use tuple unpacking. We're going to get x and y out of a function named meshgrid. And meshgrid wants x values and y values to use. So meshgrid's job is to take two one-dimensional arrays, so your x values and your y values, and give you two two-dimensional arrays that are all the x values in a 2D grid and all the y values in a 2D grid. And the beauty of that is once everything's an array, you can write stuff like, I want z to be equal to sine x plus sine y. And NumPy will understand what you want, and it's going to give you a two-dimensional array of z values. Now let's visualize our array. So we'll do an imshow. We'll give it z, and then the rest is just to customize what it looks like. So let's make it look nice. We use some of the arguments we learned in an earlier video. I like the seismic color map because we're going to have equal amounts of positive and negative values. Let's set vmin to -2. Vmax to +2. These are optional and could be omitted, but it'll help scale the color bar real nice for us. We're going to put the origin lower because I'm plotting a mathematical function. I want 0, 0 to be in the bottom left corner. And this doesn't change the visualization, but it does make the labels on the graph accurate. So we're going to set our extent here to be 0 to 2 pi. Because otherwise, the imshow has no idea what the original range of values were. Like that information doesn't survive all the way to the imshow call. We have to tell it explicitly. We're going to add a color bar, and we're going to show it. So we've got something that looks kind of cool, nice checkerboard with our sines and cosine or sine functions added together. Color bar -2 to 2. We've set with the extent command 0 to 2 pi, 0 to 2 pi. Now, if you're saying, I want this to actually have a pi symbol, there's actually a way to do that. I'll leave that to be homework for the student type thing. Look up the functions called xticks and yticks. Check out the help for how those work. They let you set where are the ticks and how do you label the ticks. But I think that would be getting us kind of off topic. Because what I want to focus on is how did this line work here? X and Y making this mesh grid for us. So let's try a simpler version of the command with fewer values, because that has a total of 10,000 values in it. So I'm going to do mesh grid, and let's just explicitly give some lists for the X and Y range. So let's just say like 1, 2, 3, 4, 5. These don't have to match each other, but I don't really have a good reason for them to be different. So we're going to do 1, 2, 3, 4, 5 for my mesh grid, and let's print what we get. I'm going to print x, I'm going to print an empty line, and then I'm going to print y. So the contents of the X array is an array. It's a two-dimensional array where at each location we get to the X value. So you can see it's a column of 1s, columns of 2, columns of 3, because as we move from left to right across this array, it represents going from X value 1 up through X value 5. Nothing changes as we move vertically in this array because that doesn't change. We're not changing the X coordinate, we're changing the Y coordinate. On the other hand, if we look at the Y array, we have rows of values, because as I move vertically, I'm changing the Y value from 1 up through 5. As I move horizontally, I'm changing X values, so that shouldn't change Y, so it's just 1, 1, 1, 1, 1 all the way across. You'll also notice if you think about your X and Y values compared to a normal coordinate system, left to right is just fine with X. Y kind of looks upside down. As we increase in Y, we have to go down. That's that whole origin equals lower business. So like internally in the computer's memory, it's stored in this way. All we have to do is just remember when we do an im show, add origin equals lower, so it shows up looking like the way we'd expect. Now let's look at how this gives us all the values we need to do something like z equals sine x plus sine y. So the arrays are great because it does all the element by element calculations very quickly for us, kind of hides away the looping and does it much faster than Python would. But we could use Python to loop through these. So let's look at all the x and y values in here. Actually, I don't want to use the names x and y, I and j, as we go through these. The zip function will let us iterate over multiple sequences at the same time. And so we can go through x and y. The other thing here that I want to do is I want to flatten these out. What that means is if I just try to iterate through x, it's going to pull out the entire row at a time. So it's going to give me a one-dimensional array, 1, 2, 3, 4, 5, and then another one, 1, 2, 3, 4, 5. That's not really what I want. I want to go through it step by step. I want to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the flatten command here, or the flatten method, takes the multi-dimensional array and it just squishes it. Show me the zip. Should we flatten? There we go. Takes it and it squishes it into a one-dimensional array. We'll do the same thing here for y. All right, so what I'm going to do now is I'm just going to print I and j. And so what we're going to see here is as we step through these element by element, we're going to start in the top left corner and just read across, read across, read across. What we're getting is every different combination of x and y values. So I have x equals 1, y equals 1, x equals 2, y equals 1, and so on, every combination. Which means that as we go through this, if we do a calculation with this, we'll visit every point in our grid that we've made. We've made a 5 by 5 grid in this example, and we'll visit all 25 of those locations. And that'll let us calculate a z value for everywhere in the grid. One more way we could visualize this is we could just plot x and y, and let's make them black dots. I guess one more thing I should do here is this graph will be a little bit squished in the y direction, so I'm going to give it a scaling command. Plot.axis scaled says make sure the x and the y axis are drawn with the same dimensions as each other. It just looks nicer. All right, so if I plot that, we can see that these points are the points in a 5-dimensional, or in a, not 5-dimensional, 2-dimensional grid 5 by 5. So at 1, 1, here we have 2, 1, here we have 3, 1, just the same as if we printed out the list. So yet another way to represent what we've created. Basically, it's just a nice way to make a grid of values. So we can use mesh grid. Let's see, look up to here. We can use mesh grid, just giving it the ranges we want for x and y, and then we can do any kind of math we want using those x and y values, just written just the same way you write out the math by hand. So it's a really nice way to create two-dimensional values.